Most tokenizers carry a hidden assumption you rarely stop to notice. They quietly split your text on spaces before doing anything else at all. And that works beautifully for English, right up until you hand it Japanese or Chinese, where words simply are not separated by spaces in the first place. That one baked-in habit quietly makes a tokenizer language-specific. SentencePiece from Kudo and Richardson at Google in 2018 throws that assumption out entirely. It's the tokenizer toolkit sitting under Llama, T5, and a whole family of multilingual models. Let's walk through what actually makes it different. So the cleanest way in is to line SentencePiece up against how most tokenizers behave. Typical tokenizers assume a whitespace step comes first. They chop the sentence on spaces and only then tokenize each individual word. That baked-in rule quietly ties them to languages that actually use spaces, and it stumbles badly the moment you feed it text where the words simply run together with no gaps between them at all. SentencePiece treats the raw text as one continuous stream of Unicode characters, spaces very much included. Rather than dropping the space the way most tools do, it encodes the space itself as a special symbol right there in the sequence. That single decision makes the whole thing reversible and completely independent of any particular language, which is a bigger deal than it first appears. To see why that reversibility matters, follow a piece of text through the toolkit. It all starts with raw text and no pre-splitting whatsoever. Whatever you hand it, spaces, punctuation, mixed scripts, goes in exactly as written, with none of the usual chopping on whitespace happening first. Next, every space gets swapped for a visible meta symbol, that little underscore style marker you may have seen in tokenized output. Because the space is now just another character sitting in the stream, nothing whatsoever about the original layout gets thrown away. At the center, it learns a subword vocabulary over that stream. And here you get a choice. It could train a byte pair encoding vocabulary or a unigram language model vocabulary underneath. It is the tooling, not one fixed algorithm. Finally, the token stream stays fully reversible from end to end. Because the spaces were preserved as symbols rather than discarded, you can join the tokens straight back into the exact original text, every space in place, which is precisely why round-tripping through it is lossless. Strip it down, and 3 ideas carry the whole toolkit. There is no white space splitting up front. Nothing assumes that words are separated by spaces. So the exact same tokenizer works on English, on Japanese, or on Chinese without any language-specific rules bolted on top. The space becomes an ordinary symbol. Encoding it directly, rather than throwing it away, is precisely what buys you reversibility. You can always reconstruct the original text character for character, which matters a great deal when a model has to generate faithful output. Underneath, it stays independent of language. It can run either byte pair encoding or a unigram model as the vocabulary learner, which is exactly why Llama, T5, and so many multilingual systems reach for it in the first place. All right, let's lock in the essentials. SentencePiece is a tokenizer toolkit built to be language agnostic and reversible, from Kudo and Richardson at Google in 2018. Rather than splitting on spaces, it treats raw text as a character stream and encodes the space itself as a symbol. That makes tokenization fully reversible and works even for languages that do not use spaces, which is why Llama and T5 rely on it. Underneath, it can learn either a byte pair encoding or a unigram vocabulary. So it is really the tooling rather than a single algorithm. If untangling this kind of detail is your thing, that is pretty much our whole job over at standarity.com. Drop by.